In exam 3, problem 5, we're toying with the notion of using a slinky as a solenoid. So we have a slinky with a diameter of 0.05 meters and a length of 0.05 meters when it's unstretched and has 100 windings. So the question is, under these circumstances, what is the inductance of the slinky? Well, let's pop over to the equation sheet where we find the inductance of a solenoid, right, is mu naught n squared A over L. All right, so in this, mu naught, of course, is just the permeability of free space. N is 100. A is pi r squared. So we're given the diameter, so we have to divide by 2 squared, right? Which is pi times 0.25 squared is, let's pull up, pi times 0.25 squared is 0.196 square meters, right? Except that I got my math off. This is, pardon me, not 0.25, 0.025. So, go back here, 0.025. There we go. Okay. And then the length is 0.05 meters. So we put all of that together. Let me go grab mu naught from the equation sheet. Make my life a little easier with some parentheses. 100 squared. The area 0.00196 meters squared divided by 0.05 meters. Okay. So we have mu naught, which is 4 times pi times 1e minus 7. We have 100 squared, and we have that, we have length of 0.05. So our final answer is this times that divided by that. Okay. So 493 microhenries. 493 microhenries. I got that because, let me go back to Excel for a second. Okay. This is 0.000493. If we change the format of that, format cells, to scientific with 2 decimal places, that works. So 4.93 e minus 4, 10 to the minus 4, so 493 times 10 to the minus 6. 10 to the minus 6 is micro, so 493 microhenries. That's part A. Part B, We change the geometry, but nothing else, right? So we stretch this link lead to 2 meters, and the diameter goes down to 0.04 meters. So now we have an area equal to pi times 0.04 over 2 squared. And so what is our new area? Right? Equals pi times 0.02 squared. Okay. So our new area is 0.001257 or 0.001257, right? Meters squared. And so we put it all together again and just copy that and edit some bits. All right. So the number of windings stays the same. This is now 12557 square meters, and this is 2 meters. All right. Double check. Length 2 meters, diameter 0.04. Okay. And let's go back to Excel. So now that's 2 meters, right? The permeability free space is the same. Number of windings squared is the same. And so it's going to be the permeability free space times the number of windings squared times the area, cross-sectional area of the loop, divided by the length. Okay. And this is 316 microhenries. 316 microhenries. 316 microhenries. Oh, my pardons. I did not realize I'd done that. Right. 316 microhenries is the new inductance after stretching this linky. And that's it for problem 5.